Good morning, students. Today we are going to discuss about module number 1, that is basic concepts. Here we are going to discuss about the concept of super mesh analysis and its problems. So let us discuss about that super mesh analysis. As we know very clear, the mesh analysis and its steps, how to apply and how to find out that unknown loop current. So the figure what I am showing here, it consists of one voltage source and the resistance of R1, R2, R3 all are connected in a T-section manner in two loops. In these two loops here we analyze the two currents as I1 and I2. So if I1 and I2 are the currents as a reference, how it is flowing in clockwise direction, what I am showing in these two loops. So this is the way how we are going to approach that mesh analysis to find out that unknown currents in those loops and the branch currents we can find out. And the number of mesh currents is equal to the number of mesh loops in the concept of mesh analysis. And the direction of currents we can analyze as our wish. Then whenever a current source which is located between the boundaries of two meshes, then it is difficult to analyze the circuit. During that case we are going to apply super mesh analysis. If you look about this figure, in this circuit diagram there are three loops. We are analyzing the three currents as I1 in loop 1, I2 in loop 2 and I3 in loop 3. If you compare that concept of mesh analysis and concept of super mesh analysis, here we analyze that one important thing, that is a current source is located between the boundaries of loop 1 and loop 2. So wherever a current source which is located between the boundaries of loop 1 and loop 2, during that case it is difficult to analyze the circuit. So for this purpose here we are going to apply the super mesh analysis. To understand the super mesh analysis, here we are applying one dotted line. So look at the dotted line. In this dotted line only I am applying super mesh analysis as by approaching the Kirchhoff's voltage law. So now I am going to apply the Kirchhoff's voltage law as to write that super mesh equation. To apply the Kirchhoff's voltage law and to write that super mesh equation, please go through that the equation as follows, like minus V plus, when current is flowing through the resistance of R1, we can write that equation as R1 of I1 minus I3 plus R2 of, when current is flowing through R2, the voltage equation is R2 of I2 minus I3. Next, when we come for across R4, where we write the equation plus I2 into R4 and it is equal to 0. So this is the way how to apply the super mesh analysis and how to write the Kvl equation. Now by simplifying this current equation, we can get the unknown three currents by simplifying either direct inspection method or through Cramer's rule. Let us go through the problem. Number 1. In this problem, for the circuit shown in figure, find I0. So look at the circuit here. In this circuit, they given that one 6 volts voltage source and one 1 kilo ohm resistor and one 4 milliamperes current source and one 1 kilo ohm resistor, another 2 milliamperes and one 2 kilo ohm resistor and another 2 kilo ohms at here. In this circuit, if we want to apply the super mesh analysis, means the first step is to analyze the currents in the respected loops. So arbitrarily here I am choosing that three currents like I1, I2, I3. I am going to take that I1 as the current in the first loop as I1, I2 is the current in the second loop as I2 and I3 is the current in the third loop as I3. So according to these current directions what I am shown in the figure 2, if we follow, we may get the equations as follows. So according to the direct inspection method from loop 1, I1 current is equal to 2 milliamperes by look at this circuit. Similarly, if you look at loop 2, we can write that the amount of the current which is flowing in loop 2, that is I2 is equal 4 milliamperes, that here we wrote by using that direct inspection method. Next, whenever we are going to look at this circuit, that is here in this circuit, I2 is the current which is flowing like 4 milliamperes, but I3 is the current which is flowing opposite to this 4 milliamperes. Therefore, this 4 milliamperes is located between the boundaries of mesh 2 and mesh 3. We can write the current equation as I2 minus I3 is equal 4 milliamperes. So I2 minus I3 is equal 4 milliamperes. This is that the equation which was wrote between loop 2 and loop 3. Now we are going to write that supermesh equation by taking the reference of loop 2 and loop 3. Please go through that figure which has been shown at here. In this circuit diagram, we are going to make a supermesh with the combination of loop 3 and loop 2. Now I am going to apply the Kirchhoff's voltage law for combination of loop 2 and loop 3. While writing that the mesh equation with applying of KVL, now the KVL equation as follows, that is minus 6 plus 1 kilo ohm into I3 plus 2 kilo ohm into I3 plus 2 kilo ohm into I2 minus I1, because 2 kilo ohm here it is located between the boundaries of two meshes, that's why two currents has been flowing here. Next, plus 1K into I1 minus I3 is equal 0. This is the overall equation. By solving the above three equations, here we are going to find out the three unknown currents. One is I2 and one is I3. So this is the way how we are going to find out the unknown currents through the simplification, and by this way here we are going to find out that the three unknown currents. So whenever there is a complexity, especially when the current source is located between the boundaries of two meshes, there is a need to apply that supermesh analysis as to overcome the difficulty, and this is the procedure how to find out the unknown currents I0 for the given circuit as by applying the supermesh analysis. Next, look at the following circuit diagram. Find the mesh currents I1, I2 and I3. So if you go through this circuit diagram, in this circuit diagram there are three meshes are there, namely mesh 1, mesh 2 and mesh 3. For suppose if it is the case where I am going to analyzing the currents of the three meshes or the three loops arbitrarily as I1 in mesh 1, I2 in mesh 2 and I3 in mesh 3. So here with the I inspection method or in direct inspection method, we can write that equation from the given circuit diagram, that is between loop 1 and loop 2. Between loop 1 and loop 2, a 5 amperes current source is located at the boundaries. So we write that the current equation as I2. We write the current equation as this because this 5 amperes current source is like I1. So we have to give the priority for I1 and we write the current equation as I1 minus I2 is equal 5 amperes. If I1 minus I2 is equal 5 amperes, that is the first current equation. The next, we have to apply supermesh analysis with respect to the meshes 1 and 2. With respect to 1 and 2, look at this circuit diagram. With respect to this dotted line, I am going to apply the KVL equation. Then the KVL equation as follows like this, that is minus 10 plus 1 into this 1 ohm, 1 into I1 minus I3, because 1 ohm is located between the boundaries of mesh 1 and mesh 3 plus again 3 into, when the current is flowing here, it becomes as I2. This 3 ohms is connected between the boundaries of 2 and 3, therefore I2 minus I3 plus 2 into I3, because it is the self resistor only for loop 3, therefore 2 I3 is equal to 0. Next, we can write that one more equation, that is for mesh 3. For mesh 3, if you apply that KVL only for mesh 3, here the equation can become as KVL equation 2I2 plus 3 into I3 minus I2 plus 1 into I3 minus I1 is equal to 0. By solving above 3 equations which has been shown at here, that is, one is super mesh equation, one is mesh 3 equation, one is the current source equation, which is nothing but boundaries of loop 1 and 2, that is I1 minus I2 is equal to 5. By solving above these three equations, here we may get I1 is equal to 7.5 amperes, I2 is equal to 2.5 amperes and I3 is equal to 2.5 amperes, either by direct inspection method or by Cramer's rule. Therefore here finally the constant equation is I1 minus I2 is equal to 5 amperes, that has been verified at here. Thank you.